Good morning and welcome to the NASA Goddard Space Flight Center in Greenbelt, Maryland. My name is Nancy Neal Jones and I'm with the Office of Public Affairs. We're sitting in the Lunar Reconnaissance Orbiter Mission Operations Center in preparation for lunar orbit insertion. The LRO spacecraft launched on June 18th from Cape Canaveral, Florida, and for the past 4.5 days it's been on a trajectory towards the moon. Now, in just a few minutes, the control engineers behind me will begin the burn that will put the spacecraft in position to be captured by the moon's orbit. We call this lunar orbit insertion. Now, the insertion burn lasts for roughly 40 minutes. Then for the next 3 days, the engineers may do a series of short orbit adjust burns each day in order to reach the desired 30 by 216 kilometer commissioning orbit. Now, to learn more about the LRO mission, let's take a look at one of the LRO videos.
I think that it's in human nature to explore.
Understanding the moon better will help us to understand our neighbors in the solar system.
We're exploring the solar system here, not just the moon.
The moon is the natural next step in our exploration of our own universe.
The Lunar Reconnaissance Orbiter is, as its namesake says, a reconnaissance mission to the moon. Our job is to take a suite of very powerful scientific instruments and make an atlas of the entire moon, in some places in very great detail. Topography, mountain heights, mineralogy, temperatures, abundances of resources, including potentially the intriguing possibility that there's water at the moon. We put all this together into a data set by flying low over the moon for a year. This is the data that the people designing the systems, picking the sites, need to take us back to the moon.
Well, we learned much about the moon from the Apollo program, but now we want to return to the moon for a more intensive study. We want to be able to go back to the moon so that we can live there for long periods and work on the moon. So we need a mission that can help us find the best places to go and determine how to go back there safely.
We know that Neil Armstrong and some of the others had a difficult time finding a safe landing site. They didn't see it till they got there, but now with our instruments we'll be able to tell people ahead of time, look, don't go there.
LRO will have a laser system that will give us a high-resolution topographic map of the moon. It also has high-resolution cameras that will identify objects that are only a foot or two in size so that we know where there are no large boulders that could be a risk to astronauts.
So our job is to literally complete the job of mapping the moon, do it at high resolutions, and enable the designers of the human systems the atlas they need to pick the safe places to go, the beneficial places to go, and where it's most fruitful to go.
In addition to the safe landing sites, LRO is looking for potential resources. And why are we doing that? Because it's really hard to carry all your supplies with you. I mean, you can do it, but you really spend a lot of not only fuel, but cargo space. So it'd be really nice to go to a place that already has the resources, whether it's water, ice to have water, or potential minerals that we could use as raw materials to make into things that we would need.
We think the most interesting parts of the moon may be the polar regions of the moon because there could be resources there. And so we're going to study intensively the polar regions with LRO.
From the Apollo era, we chose to go, for good reasons, because it was literally the easiest, to go to the equatorial regions and to stay a very short time. It was a very ambitious program, but when you look at where would you like to go and stay for a while on the moon, you begin to realize that probably the poles are the most interesting place.
Access to solar power continuously, that may be the first and most important reason over the near term. And then the possibility of resources being there. Those may take much longer time before we're able to really exploit those. But the solar power is something we can exploit right away.
The second big resource on the moon may be water ice. There's evidence from earlier missions that in dark places at the poles, there may be water at the surface or below the surface in the form of ice crystals. If it is abundant, astronauts could use this for both human consumption and as a source of rocket fuel. LRO will measure for the first time this very energetic component of the space radiation environment in order to see whether it's going to be a problem for humans or not.
It was one thing to go for a handful of days in Apollo and go when you knew that the sun was quiet, or you hoped the sun stayed quiet, and you took the risk, you calculated the risk of cancer and such, and you made a short mission. You're going to live there longer, you need to understand it well enough to go, here's what I need to do to protect myself.
One of the things that we're looking for in the LRO mission is how the high radiation environment affects our ability to explore. So if we bring cameras or communication devices, how will they be impacted by the cosmic radiation? We need to protect our equipment as well as ourselves.
When we look back on what we did in LRO and we look at what followed, I think we'll see a profound impact. We'll see us as really being the small first step where we have human beings permanently off this planet, beginning to move out into the solar system, starting with the moon. As that pans out, I think we'll be a small piece of a profound development that when history looks back, say this time we went back to the moon, this time we stayed, and we moved on from there.
So as you can see, LRO is pretty critical to NASA's mission of returning humans to the moon. And sitting with us today, we have Kathy Petty, the Deputy Project Manager for the LRO mission. Thank you, Kathy, for sitting with us today.
Oh, you're more than welcome. Welcome.
Well, Kathy, can you tell us a little bit more about the lunar insertion burn that we're here to witness?
Okay, this is LRO's most critical activity that we've been planning for over 4 years. The lunar orbit insertion burn is what we use to help change LRO's velocity, as LRO is right now falling towards the moon, and this burn will help us change its velocity so that the moon will be able to capture LRO. And once the moon captures LRO, then we'll be able to lower it into its orbit and begin our mission.
Well, this is a pretty exciting moment, Kathy.
Very.
Can you tell the audience a little bit about your role in the LRO mission?
Well, I've been very fortunate to be the deputy project manager for this project and gotten to be able to work with these totally awesome people, that the engineers that not only designed and built and tested LRO, but the people that you see behind in the control center here, the mission operations team, who work tirelessly to make sure that we're able to fly LRO and operate it to the moon and things. So I've gotten able to work with all these people and put together the whole aspects, the business part, the technical part. It's been a really cool job, and this is a really exciting moment for us.
Well, LRO was a pretty fast-track mission from conception
very
to
much. Development.
Tell us a little bit more about, building LRO and testing it, integrating it at the Goddard Space Flight Center.
Goddard, we've done a really great job here at Goddard in terms of designing and fast-tracking the spacecraft. We have a strong heritage here of many spacecraft, so we were able to take lessons learned from the many projects that we did before and put them right to use with LRO. So we didn't have to start from a blank sheet of paper. We were able to talk to our comrades on other projects and use that. So we were able to take designs and lessons learned from projects like SDO, Hubble, and all the multiple missions that we've had here, and be able to take that right into what we need to do for the LRO project. And also a lot of stuff that we do in terms of testing the spacecraft and integrating it made it just a lot easier for us, because our schedule, as you said, was very aggressive, very fast-tracked. And if it hadn't been for our ability here at Goddard, we probably wouldn't have been able to do it that quickly.
Well, that's great. Like, on a personal level, Kathy, I know from a young age you've been really interested in the moon. So has this project been a dream come true for you?
Yeah, absolutely. I got to meet my hero, Neil Armstrong, a year ago. You know, as a little kid, you know, I always dreamed of, you know, being able to work for NASA and follow in the footsteps of these totally awesome people that got to walk on the moon. And here I am, you know, with the Lunar Reconnaissance Orbiter project going back to the moon. I mean, it's just a dream come true that we're taking NASA and everyone back to the moon tonight. It's a dream come true for me and all of our team members. We're very excited.
Well, just on a personal note, Kathy, I mean, how do you feel seeing your baby, so to speak, finally getting ready to reach its destination?
I can barely contain myself. You know, I'm just so excited. I'm like nervous, happy, excited, all at the same time. And this is the moment that we've all been waiting for, you know, for all these years. So you'll probably see us all get really excited here tonight. I'll probably cry. I got a box of tissues back there because this is just a tremendous moment for all of us.
All right. Well, Kathy, thank you so much for taking the time to stop by and have a chat with us, and best of luck with the mission.
Thank you very much. Thank you for being here with us.
So, great. Thank you. Now, let's take another look inside the control room as the burn gets underway.
Flight GNC, we're on target for the burn attitude.
Copy that. Okay, we're 5 minutes out from the burn. This is the final go, no-go pull. Start with ME.
ME, go.
Systems.
Go.
FIDO.
Go.
C&DH.
Go.
Software.
Go.
GNC.
Go.
ACS hardware.
Go.
Prop.
Go.
Com.
Com is go.
Thermal.
Go.
Power.
Go.
Payload.
Go.
Deployables.
Go.
Ops.
Go.
Okay, all systems are go. 1 minute to burn start. Ten seconds. Okay, we enter Delta V.
Flight, this is ACS hardware confirming all thruster currents are nominal.
Copy that.
We see the 3-degree transient we expected flight. It's turning the corner.
Copy. Prop flight.
Guided flight.
Thrusters all look good.
Everything looks nominal.
GNC flight.
GNC.
Everything look nominal.
So far so good. I'm expecting AT5 to drop below 10% at some point.
Prop flight. Thrusters all look nominal.
That's affirmative.
Okay, we have with us today Dr. Jim Garvin, Goddard's chief engineer. So Jim, can you tell us a little bit about what's going on right now?
Well, Nancy, we're right in the middle now, beginning the critical burn, this firing of a critical rocket that will put LRO into its safe capture orbit that will allow it to begin in about a month its mapping. So this is the most important step of the mission right now that we've been dreaming of for the last 5 years.
That's just great. So Jim, you were pretty instrumental in getting this mission off the ground. How did this project begin?
Well, Nancy, it really began, if you think back to when we left the moon with Apollo, and what was left from the samples. And in the aftermath of that, we thought we have to go back. And going back to the moon to do both science and the engineering to plan for human exploration is really what began LRO. And the president's speech in January of 2004 said our first step back is to open the frontier of the moon with something like LRO. Well, now we're here, flying it.
Well, that's just great. I mean, Jim, we sent humans to the moon, 40 years ago? Why do we need to go back?
The moon's a big place, Nancy. People forget. It's got a land area the size of Africa. We surveyed and really studied 6 key places with the lunar landings, returned the samples. We looked again with Prospector, but we've left a frontier unexplored. LRO will fill in all the gaps at the scales we need for the engineering decisions to send people back there.
So, Jim, take a look at the screen. What exactly are we seeing right now?
Well, we're seeing the beginnings of the lunar orbit insertion, and over the next several minutes, the primary rocket motor will fire with the thrusters controlling it, and after that time, we will be in a capture orbit around the moon, and we'll be back for good. It's kind of like we're back, and this is the key step to do it.
Okay, so Jim, just a little bit more about what mysteries does the moon still hold?
Well, the moon is kind of Mother Nature's special chronometer, and as we think about it, we realize what we learned from Apollo told us it's part of our history. So we're interested in not only extending what Apollo did, but discovering a new moon. One of the things is, does the moon sequester resources that we could use, scientific and for people? What really is the history of the moon like? We haven't studied the poles of the moon. What is the moon like at human scales? And finally, what's the temperature space of the moon like? When we look at this planet, we think it's a simple world. But we realize now the lunar poles, you can see them now in this image, are really unexplored terrain. They're almost more mysterious than Pluto. So why not go and look at this mysterious terrain right in our own backyard? And finally, the moon actually is a piece of our destiny. So for all of us, we want to get back because we think aspects of the Earth history are recorded in that planet.
Is it true to say that we actually know more about Mars than we do about our own moon?
In terms of mapping, absolutely. In terms of understanding the samples we returned from the moon with Apollo, no. The moon has that rich textbook in those rocks and soils that we returned from Apollo so long ago. So it's a different story, but so much more to be done at this moon. LRO is our gateway.
Excellent. So just tell us a little bit about what challenges might astronauts face when we go back to the moon.
So when we go back to the moon, Nancy, ideally for a sustained presence, the things we need to know are the kind of things civil engineers plan for. Human adaptability to the lunar gravity and the space radiation, the terrain, the lunar regolith, the soil. This is critical. It's everywhere. It's in your boots, in your hands, in your hair. Well, not your hair, but it's everywhere. And so we need to look at those things as if we're going to go and live there for good. This is the kind of environment we're going to think about, and we're living now on the space station, but now it's on a new world. So that's the step that LRO has to pave the way for. So people like you could go to the moon.
Well, that's pretty exciting. So what do you think? I mean, now the moon, what's next? What do you think is next?
I think what's next is the discoveries that are going to come from LRO. This whole new moon we're ready to see is out there waiting, and this mission is going to capture it. And what that will tell us is how we should go, what we should go and ask about. And once we get people thinking about and getting back to the moon, then we can look to those farther shores, the harder places, Mars, asteroids, wherever we want to go. It's a big universe. Someone's got to explore it.
Excellent. Thank you so much, Jim. Really exciting stuff. Really appreciate you stopping by.
Thanks, Nancy. Go LRO.
Excellent. So let's take another look inside the control room.
Delta V time at 20%. $670.
T to C flight.
PNC.
All systems nominal.
So far, so good.
KCS hardware flight.
Okay, we have confirmation that the burn is underway. We're only
1-3 nominal.
600 kilometers away from the moon.
Prop flight.
Bad flight.
Thrusters are still nominal.
Everything's still nominal.
Okay, the team in the control room is hard at work. Now let's take a closer look at all the teamwork that went into making this mission possible.
The Lunar Reconnaissance Orbiter is a first step to future missions, Mars and beyond. But a lot has to happen before we get there, and one woman plays a key role.
I plan how to build a spacecraft every day. We have a large team and we have to plan every day what everybody's going to do on the spacecraft, and so I try to coordinate all those activities.
Yeah, the instruments on one side.
I have a team of people that help me out, and they take shifts and we work together to make sure that things keep moving. Well, Goddard has the responsibility of managing the mission, and we are also responsible for building the spacecraft bus and integrating the instruments to the bus and doing the system level test and integration, and then also doing all the processing down at the Cape to the launch vehicle. There's chemistry involved, there's getting the right mix of people that complement each other's skills, and when you have that all together, you can work very efficiently and come up with a great product. I think in the amount of time that we were given, that it's really we've done an incredible job trying, getting this whole spacecraft together, putting 7 instruments, which is not insignificant to put together, and I think as a team we've worked really well together to come up with a great final product.
One woman's leadership and outstanding teamwork are the building blocks of NASA's Lunar Reconnaissance Orbiter mission. Go to nasa.gov/LRO to learn more about this mission.
Well, with us now we have Dr. Lori Leshin, Goddard's Deputy Director for Science and Technology. Hi, Lori.
Good morning.
Good morning. So it's just remarkable how much work the team has put into this mission, isn't it?
They really are the dream team, this Goddard group that has put this mission together. They're doing great, and the burn's going great. We just heard we're at about 450 kilometers above the moon, so everything's going nominally. We're so excited to be at the moon today.
Excellent. So tell us a little bit from a Goddard perspective, what does it mean to have such a large role in this lunar mission?
Well, we just couldn't be more proud to be blazing the trail as the new explorers going back to the moon at Goddard. And so our team has put together a mission that's going to give us information that we need to blaze the trail for humans. We're like that advanced scout that goes out there and finds all the hazardous places and the interesting places to go, and we'll report back so that when the humans come, they'll know exactly where to go. And so to have that role, such a critical role in the mission, it's really incredible.
Well, great. Tell us a little bit more about how Goddard is prepared for this incredible mission.
Well, you know, in many ways, even though this is a robotic mission and there aren't people on it, it's kind of like sending a member of your family to the moon for us. I mean, we conceived of this mission, we designed it, we built it with our own hands here at Goddard Space Flight Center. We kind of brought it to life, if you will, and now we've sent it on its way out of the nest to the moon. So for us, there's a lot of personal involvement in this mission from hundreds and hundreds of people at the center, and who have put their time, their nights, their weekends, many sleepless nights. I know many of them would rather be asleep right now. And also I want to take the opportunity while we're talking about the amazing team to thank the families of all those team members who, along with the people who have built the mission, really helped enable it, because those people give up their time and energy too.
That's true. So, Lori, as a scientist, why do you think it's important to go back to the moon?
Well, I will tell you, as a scientist, there are many exciting things still to be discovered about our moon. It's our nearest planetary neighbor, if you will, and it's really going to allow us to read the first few chapters of the history of our solar system, which are kind of wiped out on the Earth. So the moon holds the history of the earliest part of the solar system, frankly, better than almost any other object out there. So it's got an incredible science story to tell. But more than that, I think going back to the moon is about great nations doing great things. And we have to take on great challenges as a nation, and that's one of the things that makes America, makes us who we are. In addition, I think missions like LRO are so important because they bring out the best of our spirit. They bring out the most innovative of us. They allow us to work in the high-tech areas that really help drive our economy. So there's so many reasons to be proud of this mission, not just scientific, although the scientific stuff is great too.
Well, that's great. Now, Lori, I mean, tell me a little bit more about, the Goddard community, and then at the public at large. I mean, have you noticed that people are really excited about our opportunity to go back to the moon with LRO?
Yeah, of course we here at Goddard are incredibly excited, and given, we conceived of the mission 5 years ago, we launched it 5 days ago, and 5 minutes ago we got to the moon, so it's very exciting for all of us. But the members of the public have gotten really excited as well. We had an opportunity for people to be able to send their names to the moon on a chip that's actually right now going into orbit around the moon with LRO. We had over 1 million people sign up. So absolutely amazing engagement of the public in this mission. And we ain't seen nothing yet, because when those pictures start coming down, when that information starts coming back, it's going to really transform the way we see the moon. And it's going to be very exciting.
Yeah, that's amazing stuff. Now let's take a little look at that Send Your Name to the Moon initiative.
Go ahead, Blake. Time for all look nominal.
On December 17, 1972, Apollo 17 left the moon. Almost 36 years later, NASA is going back. Are you? I'm going.
I'm going back. yo también.
I'm going.
You're going. I'll be there.
I'm going back.
And so am I.
I'm going. Try and stop me.
Wouldn't miss it. I'm going. Are you? Sure. Where do I sign up?
Okay, thanks again, Lori, for joining us. And we're going to take another look at the control room as the burn continues.
How long is the LOI do we visit before we see an eclipse?
approximately about 5 days.
Copy. Delta V time at 50%.
Copy that, 50%. Unity flight.
Flight, did you copy?
No, I didn't.
I was just saying everything still looks nominal here. Duty cycles are matching our predictions based on the trends.
Okay, copy.
Flight, we have stable capture about the moon.
Copy that, stable capture. Top flight.
Good flight.
Pressures all look nominal.
Affirmative. Pressures and temperatures look nominal.
TNC flight.
TNC?
Completely look nominal.
Yeah, everything looks good.
Flight, Fido, we've reached periapsis at 280 kilometers.
Copy that, Fido. Do we have anything on the tracking?
We have with us right now Dr. Mike Wargo, NASA's Chief Lunar Scientist. So Mike, can you just give us an update on where we are with the burn?
Well, I'll tell you, this is, we just received some of the most terrific news that we've been waiting for. The engines have been burning now for about 15 or 20 minutes, and we just received word that we've been burning long enough and we've been effective enough in those burns that we've been captured stably by the moon. So we're there. Now we're going to continue to burn so that we get the right orbit that we can then maneuver into and start to check out the spacecraft and start to check out the the instruments in the next couple of days.
Well, that's just great news. So, Mike, just tell us a little bit, how do you feel at this moment as we've begun NASA's next step to go back to the moon?
You know, it's funny. I was driving in this morning, and it's just so calm and so quiet and so peaceful outside. And yet in here, the excitement is just palpable. You've had these teams working for years now for this day. This is one of the key and critical events that has to occur for us to have a successful mission, and it looks like we're well along the way to being able to do that.
Excellent. So, Mike, you know, LRO is NASA's next lunar mission. I've asked, you know, all the scientists that have stopped by this morning to tell us, you know, why do we need to go back?
Well, going back to the moon, and we were talking to Jim Garvin a little bit earlier, and going back, we really need to be able to learn the next steps on how to live and work and be productive on another planet. When we were there for Apollo, they were unbelievably successful, but it was only for a few days at a time. Being able to live and work on another planetary surface is going to prepare us to go beyond the moon, to Mars, the asteroids, and the rest of the solar system.
Well, Mike, LRO is the first mission in NASA's Exploration Systems Mission Directorate. So can you just explain to the audience, you know, a little bit more about Exploration Systems and then LRO's role in it?
Oh, sure. Exploration Systems has been given the job to develop the equipment and the techniques and to be able to take us back to the moon so that we can be effective, we can explore, we can learn to live and work on another planet. We're going to be able to develop the capabilities to get us there, all of the equipment to allow us to live there safely, and to maneuver around the moon, to learn about the moon, as well as how to develop those kinds of techniques. We're going to be able to we're going to need to explore beyond the moon. And LRO's role in it is really pivotal. If we were going to go on a summer vacation, one of the first things we'd want to do is go out and get the best map that we possibly could. Well, LRO is going to provide a full atlas of all kinds of information about the moon that we're going to need to, first of all, develop that equipment so that it works well and works effectively, as well as to find those places on the moon where we can really understand not just the evolution of the moon, but really, as Jim was indicating, it's really a witness plate to the development of the whole solar system.
Well, you know, Mike, we know that, you know, LRO is not going to be the only spacecraft orbiting the moon. There seems to be this renewed interest in the moon internationally. Why do you think that's so?
Well, from the scientist's point of view, that interest has always been there. We just now have the opportunities from a number of nations for that as a next step in exploration and science. The European Space Agency's Smart 1 mission was the little spacecraft that could develop it demonstrated new technologies, and at the same time made measurements of the moon that hadn't been made before. Our colleagues from Japan have launched Selene and later renamed Kaguya, and it was an unbelievably successful mission and just ended recently. China has launched Chang'e 1 and is still in orbit around the moon at around the 200 kilometer altitude. And our colleagues in India with the Chandrayaan 1 mission, we have 2 U.S. instruments on board that mission, making measurements that are helping both LRO as well as our companion spacecraft, LCROSS. And LRO itself has a lunar neutron exploration neutron detector that was provided by Russia with an extraordinary team from the Institute for Space Research.
So, one final question, Mike. What does LRO mean? What do you think LRO is going to mean for the future of space exploration?
Well, I really think that LRO and the way in which the team worked together and so quickly and so effectively is a real model for how we're going to explore space in the future. The mission had an aggressive timeline. We have a great team, and that team worked together and was unbelievably flexible to take the little bumps in the road that show up and be able to respond to those, and ended up producing a spacecraft that right now is in orbit around the moon.
Excellent. Well, thank you, Mike, for stopping by. I really appreciate it.
Oh, absolutely, my pleasure.
Okay. Now let's take another look inside the control room as the burn continues.
Copy that, 10 hours.
Flight GNC.
Flight, go ahead.
Everything looks good. We're expecting AT2 to cross within its deadband soon.
Okay, copy.
Delta V time at 80%.
People listening. Copy that, 80%.
Okay, let's take another look at one of LRO's videos. LRO Scouts for Safe Landing Sites.
One of the Lunar Reconnaissance Orbiter's primary objectives is to scout safe landing sites for future manned and robotic missions to the moon. To do so, LRO's suite of instruments work collectively to build a detailed picture of the surface. Let's take a look at how this is done. The first thing we want to assess is the topography of the lunar terrain. LRO uses an instrument called LOLA that bounces laser pulses off of the surface to measure its height. The resulting map shows steep slopes, rough terrain, and gives a general idea of what areas might be level enough to provide safe landing sites, shown here in green. LRO's next step is to create a temperature map of the surface using an instrument called Diviner. Temperatures change more slowly in areas with lots of loose materials, so by looking at thermal maps, we can eliminate areas for landing that may have a dangerous abundance of rocks. The regions in yellow represent places where the thermal signatures indicate they are unsafe landing sites. Lastly, we want to double-check and refine our map even further. LRO does this with a set of cameras that make detailed pictures of the surface. Looking closely at these images, we can actually pick out individual boulders and craters. These will clearly be hazardous places to land, so we've labeled them red and removed them from our safe areas. At this point, any sites that are left green have been checked and rechecked to be level, smooth, and free from hazards. Based on LRO scouting, we would consider these safe locations to land. Let's take one more look at our process. It should be noted that while it is absolutely essential to find safe landing sites, a safe place to land is not necessarily an interesting place to land. When it comes time to pick the best landing sites, many other factors and measurements will be taken into account. As astronauts make their descent toward the lunar surface late in the next decade, they can thank NASA's Small Robot Scout LRO for showing them the safest approach.
Okay, we have with us Dr. Rich Vondrak, the LRO project scientist. So, Rich, can you just give us another update on where we are?
Well, we're right now, if the burn stopped, we'd be in a weakly captured orbit. But the good news is we only have about 6 more minutes to go, and at that point we'll be finished with our orbit for today and getting ready over the next few days to move into our commissioning orbit.
Excellent. So, Rich, as the LRO project scientist, what's your role in this incredible lunar mission?
Yeah, I have the great job of working with the 7 instrument teams, with the project here at Goddard, and then also with the instrument builders and the headquarters folks to work on the instruments. This shows the crater instrument, our radiation sensor, the lunar radiometer experiment that'll measure the temperature on the moon, our 5-beam laser altimeter, and then our high-resolution cameras, which will make very precise images of the moon, a UV spectrometer to search for water frost in the polar regions, and then a neutron detector from Russia that will look for hydrogen at the poles. And then finally, our technology demonstrator, an advanced synthetic aperture radar system. And this shows the spacecraft here at Goddard in its final testing.
So, Rich, tell me a little bit, how are these measurements that you just talked about through the other video, how will they aid humans in the return to the moon, especially for extended periods of time?
Right. In order to return safely to the moon, we have to identify a level terrain. Our 5-beam laser altimeter will measure precisely the unevenness of the terrain and identify here in green safe landing sites. We look at the temperature of the moon, and from the temperature variation we can tell rock abundances. And then finally, our camera system is able to measure objects that are only a few feet in diameter and find small craters. And by combining all of this information, we'll be able to tell where it is safe for explorers to land, here shown in green, and then after they land there, they can explore the nearby regions.
So, Rich, tell us a little bit more about what resources you're hoping to find on the moon.
Yeah, searching for resources is a very important goal. The one resource we know that is on the moon is nearly continuous sunlight. When explorers land in the equator, they're faced with 2 weeks of sunlight and 2 weeks of darkness. This video here shows the normal variation of sunlight on the moon. The moon rotates in 1 month. But here at the poles, we see that there are regions that are high elevations, like hills or small mountains, where the sun shines nearly all the time. And explorers can use this sunlight as a source of electric power and of warmth to survive for longer periods than they could at the equator. Also at the poles, we see that there are permanently shadowed regions, the bottoms of craters, that get very, very cold, here shown in blue. And we think that over the course of the last 2 billion years, water and other volatiles on the moon may have settled here, and then they've condensed and they can be used as a resource for not only human consumption but also for rocket fuel.
Well, that's just great. I think I just heard that we're about 20 seconds from the end of the burn.
That's a very important milestone.
So just tell us, I mean, hearing that, are you really excited to learn? What are you hoping to learn from LRO?
LRO is going to give us an atlas of the moon. It'll start to unlock the secrets of the moon, and there are many interesting places on the moon, but I personally am most excited about what we'll learn about the polar regions. The polar regions are the terra incognita, the unknown lands, and we think that those are going to be important destinations, and we're very excited about what we'll learn there. And now they're just telling us
all stations, this is Flight. Congratulations on a successful LOI. LRO has returned NASA to the moon.
the burn.
Okay, we're really excited here in the Lunar Reconnaissance Orbiter Mission Operations Center. We have just been captured by the moon, and we are at our, 30 by 216
We're a little bit higher than that. We're going to trim the orbit over the next few days, but the good news is we are in lunar orbit. We're not going past the moon. We're there to stay. We're ready to start doing our checkout of the instruments. Over the next few days, we'll be turning on the instruments, and we hope to make data available and images as soon as we can.
Prop flight.
Dead flight.
Ready to turn the cap heads off?
Yes.
Copy that. Ops flight. Go ahead and turn the cap head heaters off.
Copy.
I do want to, they want to do these congratulations. I do want to ask you this images question.
I just said
You did, but I don't know if they heard you. Because it was so much talking going on.
Right.
Can we? Yeah, I'm going to ask you just one question about that, and then we'll.
Chris's camera of all the shaking hands.
I have one more question for him that I want to keep him for. Okay.
We'll get back to you.
Yeah, we'll just
Okay.
just one.
Prop flight. Cap heads are off.
Yeah, they want.
Copy that.
Yeah.
Ops flight.
Ops.
Go ahead and disable pressure firing.
Copy.
Okay, as we see all the excitement going on in the control room, I have one final question for you, Rich. When will we be able to see the images from the LRO spacecraft, now that we're safely in orbit around the moon?
Yes, now that we're there, we start the job of turning on and calibrating all of the instruments on LRO. We hope to have the camera operating in the next couple of weeks, and then as soon as we get some images from our camera, we'll make them available to the public. The mission continues doing the checkout of the instruments for about the next 6 to 8 weeks, and then in August we move into our normal mapping orbit.
Well, great. Congratulations, Rich.
Well,
thank you very much.
This is wonderful.
Okay, let's go back to the control room.
And ops flight.
Ops.
Go ahead and close the HPLV valve.
Primary redundant.
Primary.
Copy. You want to leave the PD low services on or off?
You can go ahead and turn them off.
Copy.
Okay, we have with us Craig Tooley, the LRO project manager. So Craig, can you confirm that LRO is safely in orbit around the moon?
Sure, I certainly can. As the last commentator said, we reached lunar orbit. We're in an orbit that's about 200 by 3,000, which is our first initial orbit. And the tracking already shows that we're essentially where we plan to be. We're at the moon.
So just personally, how do you think, obviously you're excited because you've reached your goal, but how do you think the LOI event went overall?
It went like clockwork. You know, with a mission like this, we spent literally years, and certainly the last year, practicing for every possible contingency and being ready for this. In the end, it went exactly as planned.
Well, great. Now that LRO has finished this critical first burn, what's next in the timeline for the mission?
What we do next is, even as we speak, what's going on is we're putting the spacecraft back in the configuration that essentially it was in as we flew to the moon. We're repointing our high-gain antenna dish to the Earth to raise our data rate. We're putting it back in the mode that it's going to fly in this orbit. And that, after we get in that mode, we'll begin the work, because this was the first and the most critical burn, LOI-1 we called it, Lunar Orbit Insertion. But we have 4 more to do that take us from that large eccentric orbit we're in and begin to first lower it down to 200 kilometers and then finally put us in our 30 kilometer by 216 kilometer orbit that we'll spend the next 2 months in while we do the work to get ready to actually execute the mission.
Okay, so tell me specifically, when do the instruments turn on?
We begin to, well, we already have 2 instruments turned on, because the LEND instrument and the crater instrument, both of which measure radiation. LEND measures neutrons, eventually at the moon crater, the background radiation. Those were turned on during our transit out to the moon. So we could measure the environment as we travel there. The other instruments begin to be switched on in about a week. First, we get the rest of the spacecraft checked out, and then we begin a methodical process of bringing the instruments online, doing their calibrations in orbit, and beginning to do observations over the next weeks.
So, Craig, on a personal note, what do you hope will be LRO's legacy?
Well, I believe LRO's legacy, and I believe this says to almost everybody on this team, will be that when we look back upon this, we'll see that this small spacecraft, this unmanned mechanical surrogate for the human beings, was the beginning of when eventually we return human beings to the moon. Our legacy will be fresh footprints on the moon.
Excellent. Thank you so much
You're
for
very welcome. Thank you, Nancy.
talking with us, and congratulations.
Thank you.
Thank you.
Oh, yeah.
Well, we would like to thank all the viewers for joining us today for this critical milestone for LRO. We look forward to learning more about the moon's features, environment, and topography, courtesy of LRO. Thank you, and have a great and LRO day.
Prop flight.
Go ahead, flight.
I think we completed all the prop cleanup activities. Everything's good.
Everything looks nominal. Looks great.
ACS hardware flight.
Go ahead, flight.
Yeah. Do we have any other cleanup activities for you?
All cleanup activities have been completed.
Okay, copy that. GNSD flight. Everything looks good for you?
Everything looks good to us. We just need to switch tracker sources soon, but we got a while.
Okay, copy that. I was just going to let the ATS handle that.
Copy.
We start slewing back at around 11:36 or 11:30.
Yeah, 11:30:48 is the start of the slew.
Okay.
About an hour from now.
All right, we're just going to hang out here at 8K then.